The programmable keyboard display controller, its IC number is 8279. It was designed by Intel to interface the keyboard with the microprocessor. That is why its name is Programmable Keyboard Display Controller. Means whenever we want to interface the keyboard with the central processing unit or the microprocessor, then we use as an interface the programmable keyboard display controller. So we can say that if it is the CPU or the microprocessor, and it is the keyboard or the display unit, then as an intermediate or as an interface, we will have here the 8279 programmable keyboard display controller. So whenever we want the CPU and the keyboard, they want to transfer some data or they want to communicate with each other. So this communication will take place with this 8279. Okay. So any transfer of data, it will take place via this 8279. So we can say that this programmable keyboard display controller 8279 it interfaces a keyboard with a CPU or processor. Now what is the function of this 8279? Whenever any key is pressed on the keyboard, then this 8279, it will scan that which key is pressed, and if any key is pressed on the keyboard, then it will transfer the relative response of that key to the CPU. So that CPU will get to know that this key has been pressed on the keyboard, and the function which the CPU has to be performed will be given to it by the 8279. So this 8279, it scans the keyboard and check that if any key is pressed, and if it is so, then it is going to transfer the response to the CPU. So this 8279, it is basically scanning the keyboard and it is identifying that if any key is pressed on the keyboard, and if it is pressed, if any key is pressed on the keyboard, then it will send the relative response of the pressed key to the CPU. So this is the function of the 8279 programmable keyboard display controller. Now let us study some of the features of this 8279 IC. As the name programmable keyboard display controller says, that this is a controller which is used to interface the keyboard and the display devices to the CPU. So we can say that it is interfacing both the keyboard and the display devices to the microprocessor based systems. So its feature is that it can have simultaneous keyboard and the display operations. Keyboard, we know that keyboard is an input device. Through the keyboard, the user, it is inputting the data to the CPU. It is giving the data to the CPU. Okay, so keyboard, it is an input device, and display devices, they are the output devices like the monitor, printer. These are the output devices. So both the input and output devices, they can be connected or they can be interfaced with the microprocessor based systems. So we can say that 8279, it allows simultaneous keyboard and display operations. One of the modes of the 8279 is the scanned keyboard mode, and one of the mode is scanned sensor mode. So these modes allow to scan the keyboard, which is an input device, and the sensors or the display devices. So it is allowing both the keyboard and the display operations. Next feature is that it has a 8 character. As I have said that the 8279, it scans that the keyboard, and it checks that if any key is pressed on the keyboard. So the information about the opening and closure of the keys, that whether it is pressed or not, that information, it is stored in some memory. So this memory in the 8279, it is a 8 character keyboard FIFO RAM, and 8 character means 8 bytes can be stored in this RAM at one time, and this is first in first out. This FIFO stands for first in first out. That means the character which is first stored into the memory, that will be the first to get out of the memory, means to as an output of the memory. So first in first out memory, and it is an 8 character keyboard memory. Okay, 8 bytes can be stored. Similarly, a RAM is there for the display devices also. So here the RAM, it is of 16 character, means 16 bytes. So 8 characters, 8 bytes can be stored in the keyboard RAM, and 16 characters can be stored on the display RAM. Now next feature of this 8279 is that right or left entry 16 byte display RAM. Now, in the 8 character keyboard FIFO, its characteristic is that the character will be stored in the RAM as first in first out. They will use this feature, that the first character that will be put in the memory, that will be the first element to get out of the memory. Okay, that is first in first out. Suppose it is the memory, here the first element is stored, so this first element will be the first to get out of the memory. Okay, now in the 16 character display RAM, this RAM follows the right or left entry. Okay, means the characters will be enter either from the right hand side or from the left hand side. Okay, this we will get to understand more when we will study the modes of 8279. Next feature is the programmable scan timing. As it is this 8279, it is scanning the keyboard and the display devices. So this scan time, it can be programmed, means we have instructions, we have software instructions through which we can program this 8279 this controller. That is why it is known as programmable keyboard display controller, because programs, or we can say that the instructions and command words can be written in this 8279, so that we can can modify it or we can use it for various applications. So these were the features of the 8279. Now let us come to the topic that how we can interface the 8279 with the CPU, okay, because it is acting as an interfacing device between the central processing unit and the keyboard and display devices. So how we can interface both the CPU and the 8279, let us see. There are two modes in which, or we can say that there are two ways in which the keyboard is interfaced with the CPU. One is the interrupt mode, and second is the hold mode. Now the function of this 8279, it is to scan the keyboard and display devices. So in the interrupt mode, the microprocessor, if any key is pressed on the keyboard, then this 8279, it is going to interrupt the microprocessor and it will request the microprocessor that stop your current operation and then first see that this key has been pressed on the keyboard and you have to perform the relative response of that key. So when this mode, interrupt mode, it says that the microprocessor will be interrupted every time a key is pressed. So in this mode, the microprocessor, it will be interrupted. Interrupted means a service will be requested. Means we want the service of the microprocessor of this CPU or the microprocessor, that we want your service. We want that you make a response according to the key which is pressed. So processor is requested service only if any key is pressed. Otherwise, the CPU will continue its main task. So CPU will not be disturbed until and unless any key is pressed. If CPU is doing some work, it will continue doing its main task. Only when if any key is pressed, then only the CPU will be interrupted. So that is the interrupt mode. Now comes to the hold mode. So in the hold mode, the CPU, it is going to periodically, means at a certain interval of time, it is going to check the internal flag of the 8279, the keyboard controller, and if that flag is set or reset, according to that, it will make that the key is pressed or not. Okay, so it is periodically checking the internal flag of 8279 to check that whether the key has been pressed or not. If this internal flag is not set, it means the key is not pressed, and if it is set, it means the key is pressed. Okay, so the every time, it is not necessary that every time the key is pressed. Okay, it may be possible that it is pressed or it is not pressed. It is just checking periodically, making a check at certain interval of time. Suppose like after every 2 seconds, it is checking the flag that whether the key is pressed or not. Okay, so CPU is always, like we can say that it is busy in checking the, every time it has to check the internal flag. Okay, so a task has been assigned to the CPU that you have to check the internal flag, whereas in the interrupt mode the CPU will be disturbed only when the key is pressed. It can continue doing its main task, but in poll mode the CPU is every time disturbed, every time it has to check at certain intervals of time that the key is pressed or not. So this is the way in which the 8279 it is interfaced with the CPU. One is the interrupt mode and second is the hold mode. Now let us come to the topic that how does this 8279 works. Okay, how it scans the keyboard and how it is going to transfer or send the response of the key to the CPU. Let us see that how does this 8279 work. Now this 8279 it is interfacing the keyboard and the display devices with the CPU. So if we see a simple keyboard, then it consists of 64 keys, and these 64 keys they are interfaced with the CPU. Now this keyboard it consists of maximum 64 keys. Okay, and these keys they are interfaced with the CPU by using the key codes. So every key it will have a key code associated with it. Now when the key is pressed, then the 8279 it is going to transfer the key code into the memory of the keyboard and this 8279. Okay, so So when the key is pressed, then the 8279 it is going to store the key code of that pressed key into the 8-byte FIFO RAM. It is going to store that key code into the 8-byte FIFO RAM, and this RAM it is accessed by the CPU. So the CPU it is going to read this 8-byte FIFO RAM, and through the key code it is going to know that this key has been pressed and it has to perform the function which is associated with that key. Now, if more than because one key is pressed at a time, suppose that many keys are pressed and their key codes are stored in the 8-byte FIFO RAM, then that condition, because it can store only 8-byte. Okay, so 8-byte, more than 8 bytes keys are pressed, then that condition is known as overrun. So if more than 8 keys or 8 characters are entered in the FIFO, because this FIFO at a time it can save only 8 byte, means 8 characters it can save. And if more than 8 characters are entered in the FIFO, it means that more than 8 keys are pressed at a time, and this is when the overrun status is set. So whenever the 8 keys or more than 8 keys are pressed at a time, then this overrun status is set. Now, when a key is pressed, then the key code of that key is saved in the FIFO. And now, if the FIFO RAM it contains a valid key entry, means it shows that a key has been pressed. Valid we are saying because whenever 8 keys are pressed or more than 8 keys are pressed, then that is not a valid key entry. So here we are saying that if the FIFO it contains a valid key entry, then the CPU is interrupted in an interrupt mode, else the CPU checks the status in the polling mode to read the entry. Okay, as I have said in the that how we can interface the keyboard with the CPU, I have explained the two modes, interrupt mode and the polling mode. So here I am saying that if a FIFO it is containing a valid key entry, then two things can happen. In the interrupt mode, the CPU will be interrupted, or in the polling mode, the CPU it is going to check the status of the flag. Okay, so here I have written that if FIFO contains a valid key entry, then the CPU is interrupted in an interrupt mode, else the CPU it will check the status in the polling mode to read the entry. Okay, so the CPU is getting the information that this key has been pressed, and the response of that key is provided by the CPU, means the function which is associated with the key which is pressed will be performed by the CPU. Okay. Now, once this entry which is there in the FIFO, it is read by the CPU, then the FIFO it is updated and the key entry it is pushed out of the FIFO to generate space for the new entries. So suppose this is the FIFO RAM, and in this FIFO the information about the key which is pressed it is stored. Okay, suppose this information is XXS. Now this information it will be read by the CPU, and once the CPU has read the information about this key pressed and it has read it, then this entry which is there in the FIFO it will be pushed out of the FIFO, so that the new key code entries or the new entries of the key which is pressed that will be stored in the FIFO. Okay, so in this way the 8279 it is working. It is first scanning the keyboard that if any key is pressed or not, and if it identifies that a key has been pressed on the keyboard, then it is going to store the key code which is related with that key pressed into the FIFO RAM, and then this RAM will be read by the CPU. CPU will get to know that this key code is there in the FIFO RAM, and this key code is associated with this key. So that function which is associated with the key will be performed by the CPU, and then this FIFO RAM will be made empty. This entry will be pushed out of the FIFO RAM so that the new entries can get space into the memory. They can be stored in this RAM. Okay, so in this way the 8279 programmable keyboard display controller works. So in this video we studied about some of the features of 8279. Then we studied that how we can interface the keyboard with the CPU, the two modes, interrupt mode and the poll mode we studied. And then we studied that how the 8279 programmable keyboard display controller works. So I hope that this topic is clear to you. Thank you.